Students, a very good morning from Professor Mohit Rastogi from Navchetna Gurukulam. So, how are you doing, students? So, in this next video, in continuation with integration part 1, this is part 2. Before I'll start with this video, I would just like to summarize what we have done in the first video. In the first video, we had learned what is integration. Indefinite integration. We learned about the arbitrary constant which is added to the integral. Then second, what we did was that what is the meaning of integration? I mean, if integral is considered as a function and if we want to graph it out, then what does it mean? Third thing which we did was we started with simple integration. In simple integration, we did two formulas, in fact one formula and a subpart of it. The first formula involved integration of x raised to power n dx, that is x raised to power n plus 1 upon n plus 1 plus c, where n is not to be used as minus 1. Apart from it, any real number can work out. Then second thing which we did was ax plus b raised to power n integration. That is, in place of x, if we have ax plus b, then what we are supposed to do? It would be ax plus b raised to power n plus 1 upon n plus 1 into, in the denominator itself, into a, and of course plus c. Now what I would like you to emphasize upon is that if it is not ax plus b, let us say it is ax square plus bx plus c and whole raised to power 3. Then don't do ax square plus bx plus c whole raised to power 2 plus 1 upon 2 plus 1 into derivative of ax square plus bx plus c, that is 2ax plus b. I mean, that's why I don't want you to remember like the way that in the denominator the differentiation of ax plus b has to come. So I don't want you to remember like that. So only if in place of x there is a linear in x, then only this formula works out, otherwise no. Ax square plus bx plus c whole raised to power 3 can not be worked out the way which we did just now. It won't be done in that way. Understood? So even if you have tan cube x, then don't do it by that way. Tan raised to power 3 plus 1 x upon 3 plus 1 and derivative of 10x multiplied in the denominator. No, it's not done like that. Okay? But otherwise the integration, half of the integration would finish. It's not done like that. Now we go to the next formula in the series. Simple integration we were doing. Now in simple integration we do write the second form. The second formula which we will do is integration second formula we are doing. First part, integration of 1 by x. Now integration of 1 by x, so you have to try to remember that whose derivative is 1 by x, that is ln of x. In fact, mod x has to come because x has to be taken as positive only, plus c. And in continuation to it, second formula which I would like to introduce is if instead of x you have a linear in x. A linear in x, that is ax plus b. Please do remember only a linear in x, what is we are focusing at. So this would be 1 upon ax plus b, sorry. Ln of ax plus b and divided by 1 by a plus c. So that you should count it as coefficient of x. That's all, the only thing which you will say. So this is the formula which we have learned, and now what we will try to learn is some questions based on that. So first example 1. So example 1, as of course I'll not give a simple one. There would be definitely a twist in it. You have x raised to power 4 plus x raised to power minus 4 plus 2 upon x cube. How you are going to handle this? So, as usual, earlier I also told you that you always have a rough paper ready with you or a rough notebook, and of course with a pencil or pen along with it. And then you should pause the video and then you should see how it is. You should try by yourself. So I presume that you have paused the video and I am giving you the solution to it. Okay? So, x raised to power 4 plus x raised to power minus 4 plus 2, I can write it as under root x square plus 1 by x square whole square. Am I right or wrong? Because when you expand it, I mean, not a good 2 I have made. Yeah, now that's better. Now x square plus 1 by x square whole square, that becomes of the numerator, and in the denominator you have x cube. No worries. Now what will come out of it? Now here I would like to emphasize upon one very important concept or a theoretical point in itself, that is, whenever you have x square, I think this is not visible enough, so I'll make use of another color. So which color you would prefer? A blue one, let's say. No problem. So whenever you have under root x square, can somebody answer me? What will you get out of it? So somebody will say plus minus x. That would be wrong. It's not plus minus x, it is mod x. From the under root quantity, you get only a positive term out of it. Okay, students? So that's the way you need to do. So please make a note of it. So here, what there would be a difference? Will there be a difference here? Now x square plus 1 by x square mod 1 will come, but since x square is positive and 1 by x square is positive, so mod actually do not matter. What actually will come out as x square plus 1 by x square only. You can let go of the modulus sign because this in itself is positive, so modulus is not required. Now you will split the terms. X square by x cube will fetch you 1 by x dx. You will separate out the integrals, and 1 by x square upon x cube, this term upon this term will fetch you 1 upon x raised to power 5 dx. Now of course x square and x cube will, when gets multiplied, the powers gets added. So 1 by x integration would be ln x. Now here I'll have to write mod x, and 1 by x5 integration the same way which we did in the previous video, that is x raised to power n. So x raised to power minus 5 plus 1 upon minus 5 plus 1 plus c. So this would be your answer finally. Is that okay, students? So that's the first question for you, and we move on to the next question. We take the second question, second example. We take the second example, and in the second example, of course, Mohit sir will not be leaving you in a comfortable position. I'll not leave you in any comfortable position. You will definitely have to, okay, I'll do it like this. Okay, that's better. So students, the second question. Okay, in the meantime I'm writing. You can always write that. Example 2. Okay, I'll use a black pen. And that is x upon a plus bx. Now what is this? There is x in the numerator, there is a linear in the denominator. I only gave you the formula for linear in the denominator. How would you handle this? Okay, tell me. So this one would go yes, students, I hope by now you have done it. So what in here you have to do is that whenever the degree of the polynomial, oh, what term I have spoken of, degree of a polynomial. Now let us come back with some concepts of degree of a polynomial. And I have used the word polynomial as well. What is a polynomial? Okay, a polynomial is an expression like an x raised to power n plus an minus 1 x raised to power n minus 1, like that, so on till x naught. X naught means x raised to power 0. Now, okay, I'll write rather than speak. It is a polynomial is an expression like this: a naught x raised to power n. I have changed the variable, the constant, a1 x raised to power n minus 1 plus a2 x raised to power n minus 2. Of course, the variable is x, and a naught, a1, a2, etc. are constants. And the last one is a naught. And the power is x raised to power 0. This expression is known as a polynomial, whereas n is the degree of the polynomial and it is a non-negative integer. So whenever, now here considering x, it's a monomial it's a one term only, and here it is a binomial, and it can also be called as a linear in x. Now they both have degree 1, that is the highest power of the variable occurring here. Now whenever the degree of the numerator and denominator is same of a polynomial, obviously degree of a polynomial, that's what we are referring to. Now in that case, you will write the numerator exactly in terms of the denominator. So how would you express? So you would express it in, now b is the coefficient of x here. So what I'll do, I'll multiply and divide by b. Am I right, students? And what else I'll do? I'll add and subtract a. So I'll add and subtract a. So I'll write a plus minus a. Isn't that correct? So a and a gets cancelled, only bx is left. And when b and b gets cancelled, only x is left. So this expression is exactly equivalent to this integral. Okay. Now I'll separate out this bracket term. I'll separate out 1 by b integral a plus bx. That's pretty amazing that the way I'm making a bx dx, and what is left is a minus 1 by b. A is inconsequential so far as integration is concerned. It is just a constant. So here you will have a plus bx dx. So what would be the integration of this guy? This and this cancels, 1, 1. And what would be the integration? Integration would be 1 by b as such. One integration is x. And here it's a linear in x in the denominator. So I'll make use of this formula. Am I right, students? So here it was ax plus b. Here it is a plus bx. So what I'll do, I'll have minus a by b. And 1b from here. So it will become b squared ln of a plus bx. Correct? So this would be your answer. Very well. So I hope you could understand. Here what we have done is we have learned about what is a polynomial. A polynomial one variable is of this type, in which the power n, which is the highest degree here, which is the highest power here, is a non-negative integer, while a0, a1, a2, etc., a0 are constants. They are real provided it's a real polynomial. You will also deal with complex polynomials. Just for knowledge sake, I am telling you, it can be a complex number as well. So no worries. We have complex polynomials as well. So only in that case we make use of a0, a1, a2, etc. as complex numbers. We'll be using the same when we'll be doing coordinate geometry of complex numbers. So next question we come to. So again, next question. So we will just remove this all, and this alone is left. This is gone. Okay, students, next question being example 3 in the same category. You have x in the numerator and you have x square plus 2x plus 1. Okay, how do you handle this? Now here there is a quadratic in the denominator, there is a linear in the numerator. How would you handle such kind of question? So I would request you to attempt it on your own, and then later on see the solution. And no matter, even if you have done this question, then also look at the solution properly, because I may add up something or the other in your knowledge. I know. So what I'll do, I'll write it. I realize that the denominator here is a whole square. Isn't that so? So I'll write it x plus 1 whole square. Now, having written like this, I can write plus 1 and minus 1 in the numerator and see what magic I produce. X plus 1, I put it in a bracket, and minus 1. So adding and subtracting a constant in the numerator is a common phenomena in indefinite integration. This thing you should keep in mind. So x plus 1 upon x plus 1 whole square you will get 1 upon x plus 1, and you will have a dx, of course, and minus 1 upon x plus 1 whole square. So instead of 1, I'll write dx, and here it is x plus 1 whole square. Isn't that right? So 2 I have not made properly. So 1 upon x plus 1 integration would be same as the second formula. So what you will get here is, finally you will get ln of mod x plus 1. This is the integration of this fellow. And integration of this fellow, 1 upon x square. It can be written as x square means linear in x. So 1 upon x plus 1 whole square means the same thing. The x plus 1 raised to power minus 2. Its integration would be x plus 1 raised to power minus 2 plus 1. The same formula which we did it in the previous class. I hope you understand. So this minus and this minus would cancel. You get a plus. So final answer being ln of x plus 1 plus 1 upon x plus 1. That would be your final answer. I hope you understand this. So in this question we realize that when the degree of the numerator is lesser than the degree of the denominator, how we have handled. This is not, of course, the model way of solving when the degree is 1 less, but yes, in this question we did it like this. I'll make use of one more question to exemplify the point which I wanted to give you. That is example 4. I think this is fourth one which I'm dealing with. So here what I do, I have the degree of the numerator greater than the degree of the polynomial in the denominator. I do it like this. Okay, how would you handle this? So no worries, give it a try. So keep trying. In the meantime, so whenever the degree of the numerator is higher than the degree of the denominator, you actually do the expansion of the numerator. Nothing else can be done. X cube, I hope you remember a plus b whole cube formula. X cube plus 3x square plus 3x plus 1 upon x. You simply separate the terms and then one by one keep on integrating. So x cube upon x, what you will get? X square. 3x square upon x, what do you get? 3x. 3x upon x, what do you get? 3 only. And in the last you get 1 upon x. Now each integral is doable. Till now whatever you have done, you can do that. X square integration is x cube by 3, isn't that so? 3x integration would be 3x square by 2. 3 integration is 3x. And 1 by x integration by the formula which we have done this time, that is ln of x. So I hope you understand. So just revising it once more, there's the second formula which we are considering for simple integration. So this is done and we have exemplified enough. We go to the next portion. So the next portion involves another tip from my side, that is, let's say, so here the formula will be, third formula which I'll emphasize upon would be first integration of e raised to power x. E is the exponential number which we are referring to, that is e raised to power x itself, because the derivative of e raised to power x is e raised to power x. And suppose instead of e raised to power x, you have e raised to power a linear ax plus b, then you will have e raised to power ax plus b, and here denominator, the coefficient of x would come and a constant term c. Third formula which slightly varies, it is a raised to power x, that is any positive number except 1. This integration goes as a raised to power x log of a or ln of a, log of a to the base e. Since I'm writing log, so I've added e. Okay. And similarly, if you have a raised to power px plus q, that's a linear. In that case, you will have a raised to power px plus q. Now the coefficient of x is p would come along and log a to the base e. And of course, a plus c in both the cases. So these are the formulas. Please make a note of them. These are direct results. How they are coming, how I am coming up with these formulas, just the reverse process of differentiation. You differentiate this guy, you will get this guy. A raised to power x derivative is a raised to power x log a to the base e. So log a cancels, a raised to power x remains. That's what. So I'll do few questions based on this. So we'll start with a simple question. not a very simple question, but yet it is a doable question. So you have 2 raised to power x plus 1 minus 5 raised to power x minus 1 upon 10 raised to power x. How do you integrate? Yes, students, the question is simple enough if you see that it can be done. Now you all have to try it by yourself. In the meantime, I'll solve it. So 2 raised to power x plus 1 can be written as this, and this I'll separate. 10 raised to power x, I'll write it as 2 into 5 whole raised to power x. Can I write like this? Now there is a formula which we learned in a into b raised to power x is nothing but a raised to power x into b raised to power x. In exponentials, we learned this. Radical and exponents, we learned this formula. I hope you remember this, students. So, just making a note of it. So, in any case, if you have forgotten, you can note down this. Now, that means 2 into 5 raised to power x can be written as 2 raised to power x into 5 raised to power x. That's what. So 2 raised to power x plus 1 can be written as like what? It can be written as 2 raised to power x into 2 raised to power 1. Can I write like this? And I'll split it. So 2 raised to power x into 5 raised to power x is in the denominator. You have a dx and minus 5 raised to power x minus 1 can be written as 5 raised to power x into 5 raised to power minus 1, and the denominator contains the same 2 raised to power x into 5 raised to power x. Isn't that right, students? So 2 raised to power x, 2 raised to power x gets cancelled. 5 raised to power x, 5 raised to power x gets cancelled here. Rest is simple only, just application of the formulas. 2 is a constant, it would go outside. It is 5 raised to power minus x dx, and here it is 5 raised to power minus 1, that is 1 by 5 will go outside, and integration of 2 raised to power minus x. Okay. Now 5 raised to power minus x integration would be done by this formula or this formula? This formula, because you have a coefficient of x here that is minus 1 rather than 1 coefficient. So you will have 2 into 5 raised to power minus x upon minus ln of 5. Instead of log 5 to the base e, I can write ln of 5. Here what do you get? Minus. Minus will come from here, and this minus will make it plus 1 upon, you understand now? 2 raised to power minus x integration would be 2 raised to power minus x upon ln 2, and minus 1 will also come along, and this minus will become plus. Isn't that right? So this is the answer which you get. I hope you understand it. Now next question being, so next question, I hope till now you are gliding through the portions. So the next question is also from the same category, example 2. And let this time we have, 2 raised to power x into 5 raised to power x. How would you handle this? Or maybe 5 raised to the power 3x. How would you handle this? How would you handle this? And dx. So, what you can do here is, what you can really do, you can write it as 2 raised to power x, no doubt. Here, can you write 5 raised to power 3x like this? 5 raised to power 3 whole raised to power x. Can you write like this, students? No problem, because we know that a raised to power x whole raised to power y is nothing but a raised to power xy. So writing it in opposite. Correct only? So this is what we can handle. Now, this is reduced to what we can handle as of now. We'll have 5 cube as 125. So 2 into 125 whole raised to power x. Can I write like this? Because x is the common power to both of these terms, so I can write like this. Isn't that right? So it would be 125 into 2 is 250. So 250 raised to power x upon ln of 250. Now, there can be a slight change in the formula, change in the answer which you get. You can write this also as 250 raised to power x ln of e, okay, to the base 250. I mean, base changing rule is what I have used. Aha, what is base changing rule? So the base changing rule goes like this. I'll just tell you that suppose you have log a to the base b, and suppose due to some reason or the other you don't like b as the base, so you can write it as log a upon log b, and whatever base is okay within the mathematical domain you can put in here. So if you actually put the base as a, then log a to the base a will become 1 and it would be log b to the base a. So that means that reverse process would happen. I hope you understand. Now what I said is, if k is a, so what this will become, log a to the base a, that will become 1, and log b to the base a, that means a to the base b will become b to the base a, 1 upon b to the base a. So that's what I've done. It was log 250 to the base e, 1 upon log 250 to the base e. I wrote log e to the base 250. I hope this is okay with you, students. Now, having done this, we move on to one more question. So, till now, the ride was very simple enough. We were making use of good number of formulas of exponential and radicals, and we were also making use of logarithmic formulas. Now, the next question is, e raised to power 3x plus, so slightly of different type, e raised to power 5x upon e raised to power x plus e raised to power minus x. This you need to integrate. A little thinking would be required here. So, how would you do that? So, I mean, it's very, intuitive. If you take e raised to power 4x common from the numerator, Instead of this guy, what will remain? Tell me. Isn't that e raised to power x instead of this? If I take e raised to power 4x common from the numerator, e raised to power 4x into e raised to power x, 4x plus x will give you 5x, so it gives you back this. Now, what instead of e raised to power 3x you will get? You will get e raised to power minus x. Am I right? Because when e raised to power 4x gets multiplied to e raised to power minus x, since the bases are same, the powers gets added, 4x minus x will give you 3x. So you get 3x back. I hope you got it what I said. No, not understood. Okay, do one thing. You just multiply it. So e raised to power 4x and e raised to power x, what do you get? Bases are same, powers gets added. 4x plus x gives you 5x, so you get this term. E raised to power 4x and e raised to power minus x, bases are same, powers gets added. 4x minus x will give you 3x, so you get the numerator. I hope you got this. Now here, of course, it becomes very easy. So far we guys are concerned. The numerator, we catch hold of the denominator inside it. E raised to power 4x is left, and this is nothing but e raised to power 4x divided by 4 plus c. So that's the answer. And this is okay. I think this. So students, till now we have done all the formulas of simple integration. That is, when we do the differentiation as a reverse process, we get the term whom we are integrating. So this is understood. After this, in the next video, I'll come up with trigonometric formulas, trigonometric functions integration. So there again we'll do some good questions. So I think stay connected till then and stay cool. Bye-bye. Bye.